This is the continuation of the previous discussion, which is inverse proportion. So we learned that before. The equation of inverse proportion is k equals to x times y, or x equals to k over y. Or it also can be y equals k over x. Yeah, if you exchange or you swap the x and y. So there are three different forms of the inverse equation that you can make. Okay, so we're gonna go to the work example 13. Yeah, you can open your textbook. So if y is inversely proportional to square root of x and y equals 6, when x equals 4, calculate the value of y when x equals 16. So here we can use the equation of the inverse proportion, the one on the previous slide, to find the k first. So you can see that on your textbook, the textbook is using a different approach, which we can discuss later at the end of this this explanation about this question. I'm going to go to the next slide first, which answering about the second question, which is find an equation connecting x and y. So let's find the equation first. Using the equation on the previous slide, which is y equals to k over x. This one. Okay. But what you can see here is not y equals to k over x. Instead, y equals to k over square root of x. Now, how did this happen? Let's go back to the question. It says if y is inversely proportional to square root of x. So instead of inversely proportional to x, the question said that y is inversely proportional to x, square root of x. Well, that means we have to change the x into square root of x. And here we are. So we have a new equation, y equals to k over square root of x. If you are confused a bit about it right now, just think of it as like the special request of the question. So again, usually the formula is y equals to k over x, but now the question have a special request, and they ask you to change the x to square x. Yeah, you can think of it like that. So we just change x into square root of x, just like the question specially asked. Okay, now we do the same thing as we did before, which is we just write the equation directly, so y equals to k over square root of x, and then now we put in the y and the x, the value of y and x into the equation. So let's get back to equation first, to the question first. Y equals to 6 and x equals to 4. So we put in this 6 and 4 into the equation, here and here. Now notice that even the number 4 is specially designed for this question, because they ask you to add a root here, right? So the number they give you should be a number that can be rooted. So 4 is a perfect number to be rooted, which is 2. Imagine that if the question give you another number like 5, 6, 7, 8, you can root it just like that, right? So again, this is a specially designed number for a special request by the question. So don't get confused by the square root of x, okay? Okay, and then we root the 4, we got 2. And then the k will be 2 times 6, yeah, something like cross multiplication. So once you get the k, you restructure the equation, y equals to k over square root of x. is that just now the k, you already changed it to a number. So the k is not k anymore. As I mentioned before in the previous discussion, that when you form an equation, you put in the value of k and leave the y and x just like that as an unknown variable. Okay, and then after you get the equation, you can answer the number 3 and number 1. Let's go to number 3 first. Find the value of x and when y equals to 4. As I also mentioned before, the moment you get the equation already, whenever you are given the value of x, you can find the y. And if you are given the value of y, you can find the x already. So that's what we do. We just rewrite the equation, and then we put in the value that the question gives, which is the y. So what we are doing here is we are replacing the y with the 4. See? Okay, and then with the cross multiplication thingy, we can swap the square root of x and 4. So they like exchange place, and then 12 over 4, 3. So if square root of x is 3, that means x is 9, right? Yeah, the way you get it is like you can use the logic like what number when you root it you can get 3, right? Which is 9, or you can just move the root to the right side here, and it will become the reverse of the root, which is the power. So it will become the 3 to the power of 2, which is 9. And then after we are done with number 3, we can go back to number 1 again. Calculate the value of y when x equals 16. Okay, we can use this equation again, but this time we put in the x, right? So 12 over square root of 16, which is 4. So 12 over 4, 3. So the y will be equal to 3. Okay, now let's get back to the explanation that the textbook gave on the number 1. We can see that the textbook is using a different approach, but still give the same result, right? So what we are doing here is, this is kind of just a logical way. So like, it says when x is 4, y 6. So when x is 16, here we find the ratio of the x given between the x asked. So the ratio of the x, 1, let's call this x1, and x2 is 4 over 16, which then we can simplify to 1 over 4. Okay? And then what we do here is we root both. So we root the 1. So square root of 1 is just 1. That's why it's just written 1 like that. And the square root of 4 is 2. Yeah, we root because, again, the question asks you to root the x, right? Okay, and after you can find the ratio, which is 1 over 2, you times with the y given to find the y that is asked. Okay, that's how number 1 is done according to your textbook. If you can understand this way, you can follow this way, but I don't really recommend you to use this way. You can again get back to the way that we usually use, which is just use the equation that we found on the second question. So that's it for this work example. Let's move on to another one. Okay. Now, problem involving inverse proportion. So, yeah, you can read the question by yourself, but don't be confused with this kind of complex an advanced question. The important thing here to note is that it says here that V is inversely proportional to P. Okay, that's why we write V equals to K over P. So the role of V and P here is to replace Y and X, right? It can be the other way, replacing Y and X or X and Y. So you can write V equals to K over P here, or you can write P over is equals to K over P. Is up to you, and the answer will be just the same at the end. So because they say here V equals to K over P, we just follow. And the next thing you should know here is that it says the pressure, which is the P here, is 50 PA. It is a shortened form of Pascal. So because pressure is P and the pressure is 50, that means P equals to 50. Okay, and then it says here V equals 1. Yeah, where's this coming from? Coming from here. 1 dm cube. So dm cube, yeah, is a unit of volume. It even says here V dm cube, right? You see that it has, they have the same unit, right? So this must be the V. So now we are doing the same thing here. We put the P and V into equation to find the K. K50. Reform the equation, restructure it, and then they ask to calculate the V. Oh, sorry. When the P is 1250, so you just put in the equation again to find the V. Same thing. Okay, this is also the same thing. It's just like the kind of like the real life problem, the long one that is confusing you. But the one thing that you should note here is that it says here S is inversely proportional to T minus 2. That's how you form this equation. So whenever you encounter this kind of problem, you just try to look for the word inversely proportional. That's the first thing you need to do. So you form the equation first. The moment you have equation in front of you, you can determine the next step easily. And then you just follow the same thing like we usually do. Yeah, form equation, find the K, and put in one of the value to find another value that is asked by the question. Okay, this is another work example, which is the last one. So yeah, this is just the same. This one is even easier than this one. So I bet you can understand the moment you read it. So that's it for today's discussion. I'm going to see you on the next discussion.